Hi, my name is Berkay and here I am with another video. In this video, I will going to show you how to calculate full width at half maximum value of a Gaussian signal. In this MATLAB file, I have a corrupted Gaussian signal, and in this section, I have calculated its full width at half maximum value and I have plotted it. In the next section, I have smoothed out that corrupted signal, and you can notice that I have used several different smoothing techniques. I have used several different smoothing techniques because I want to find out which one of them is better for this kind of data. And I have compared them with each other in here. And lastly, I have upsampled my smoothed out signal and I have recalculated full width at half maximum value again. Now let's start. First, I have loaded my corrupted signal, and as you can see, it has three components. One is corrupted data, other one is signal, and next one is time. So let's see our corrupted Gaussian. Now this is our corrupted Gaussian signal, and you can see it's a little bit noisy, and you can notice that it's irregularly sampled. So what I will going to do is I will going to find this signal's full width at half maximum value. So to do that, first I need to find the peak value, because full width at half maxima is equal to time length between 50% gain before the peak and 50% gain after the peak. So first I need to find the peak point. And to do that, I need to normalize my signal. As you can see in here, I have normalized my signal, and what I basically done is I had divided my signal to its maximum value. And after that, I have found the peak point and I have used find function for it. So basically, when my normalized signal's value is equal to its maximum value, it will going to assign that data point, and it will going to assign that data point to in here. So after that, I have find the half gain point. To do that, I have used the search and function, and it will going to search for the half gain point from the start of the signal to the peak point. So basically, it will going to search this area, first half of the signal. And after that, I have found the second half gain point. Again, I have used the search and function, but this time it will be start from the peak point and to the end. So it's basically the second half of the signal, but you need to be careful because MATLAB will going to assign the peak point as a starting point. So let me show you what I meant with that. So let's look at second half point. So when we done this, it find this value 0.6 seconds. So MATLAB show us that second half gain point is around here. That's because it is 0.6 point away from the peak point, and it's actually should be around here. So I just need to adjust it a little bit. So I have added the peak point and add a -1 for the adjusting. So let's do that and let's see again. Now it is 1.3 second. So it is around here. Then I have calculated the full width at half maxima and I have plotted it. And let's see. So as you can see in here, this is the peak point, the red one, and green one is the first half gain point and second half gain point. and full width at half maximum value is 0.9. And this is wrong because I don't know if the real peak value is in here. This is a noisy signal, and as you can see in here, uh, first half point and second half point is not the same, so these two were wrong again. So what I'm going to do, I'm going to smooth out this signal and resample it. So in here I have smoothed out this signal and I have used several different smoothing out techniques. First one is rectifying and low pass filtering. So rectify is a very cool word, but only thing you are going to do is take absolute of your signal. And after that, you are going to apply a low pass filter. And your filter kernel will be bunch of ones that divided by k. And this is it. Second technique I have used is magnitude of Hilbert transform. So Hilbert transform help us to calculate complex analysis of our signal with using signals real values. So it is a really good smoothing operator. So you will just going to use Hilbert function, and after that you will take its magnitude, its absolute, and after that you will going to apply a low pass filter. Then I have used running variance. So what running variance basically does is it will going to calculate steady state deviation of my signal for each data point from start to end. So it's a really useful smoothing technique, and I have put all of them in together in here. So blue one is the original signal, red one is the rectified signal, and yellow one is Hilbert, and purple one is running variance. So running variance really underperformed in here, but this doesn't mean that this smoothing technique is bad. It is just underperformant for this kind of data, and you can say that Hilbert is underperformant too, or overperformant, because you can see that it's started good, but it really end bad. The most beautiful one is rectified signal, and it is almost same, but we will compare them in here too. So you can see I have used call cohere function, and this will give me a number of similarity, and I have take square of that number. So I have done this for the every other smoothing out techniques. So let's see. As you can see, rectified signal is 0.99, similar, almost perfect, and Hilbert is 82 points, and poor variance is 52 points. So we are going to use rectified signal for our upsampling, and in here I have specified sampling rate and created a new time vector and use graded interpolation function to interpolate my signal. And after that I have calculated new peak value and new first half gain point and full width at half maximum value. And let's see. Now this one is the smoothed out signal, and as you can see in here, full width at half maximum value has changed, and it is now equal to 1.048. The peak value has changed, and you can see in here our second half gain and first half gain is same. Now this is it. Thank you for listening to me. In this video you learned how to find food with at half maximum value, and you learned how to compare different kind of smoothing techniques, and you learned how to resample your data. Thank you for listening to me.